All right, so I think I'm recording here. Let's take a look at these two problems, these absolute value inequalities. Um, in each of these now, I can see that on the left-hand side, I have two terms, and I want to get the term that has the absolute value by itself. So right away in problem number 5, I'm going to subtract 6 from each side. When I do that, I have the absolute value of 5x is strictly less than 45. And now I notice that the arrow is pointing towards the absolute value, so I know that in my solution set, the center portion of the number line is going to be my solution set, not the tails. So to drop the absolute value symbols, I change the positive 45 to negative 45, and that's strictly less than 5x, which is strictly less than 45. So even though there's three portions to this, we can still think of this idea of balancing. I'm going to divide every section, all of these numbers, all of these terms by positive 5. So a negative 45 divided by a positive 5 is negative 9. 5 divided by 5 is 1. And 45 divided by 5 is positive 9. So let's go to a number line. Let's look at negative 9 and positive 9 and recognize that those are our critical points, our boundary points, the endpoints of our solution set. And we look up again and we say, well, this negative 9 less than x less than 9 is telling us to shade the numbers that are between, strictly between these two values. So our solution set to this original absolute value inequality is negative 9 to positive 9, excluding those endpoints. Now let's come over and take a look at this next one. The absolute value is not isolated, so I need to add a positive 5 to each side. That'll cancel that negative 5. And I'll have negative 4 plus 5, which is 1. Oh, and I'm sorry, when I first looked at this, for some reason, I think that I mentioned that the absolute value, the arrow was pointing away from the absolute value, and it's not, it's pointing towards. So it's the same situation that we have here in problem number 5. I can write this as a compound inequality by saying negative 1 is less than or equal to x divided by positive 10, which is less than or equal to 1. I can multiply all three sections of this by positive 10, and we have our inequality that describes our solution set. If we sketch that on a number line, negative 10 and positive 10 are our critical points, our endpoints. And since we have this underlined portion, this equality, we shade these endpoints. We include them in the solution set. And this is a compound inequality that's and we shade in the middle just like we did before. This time we have brackets on our endpoints. And here's our solution set for problem number 6. So I hope that helps, and I will talk to you later. Bye.